Hello, welcome back. Today I will solve LeetCode 739, dairy temperatures. We're given an integer array containing dairy temperatures. For each item in the array, we have to determine how many days we have to wait until we have a higher temperature than the current one. If we are not able to find such a temperature, then we just assign the value 0. Let's take a look at this example. We are given the temperature array. This is the array that we need to return. Let's walk through this together and see how we obtain the answers array. The first item is 73, and we have to find the day in which the temperature gets warmer. So we look through the array from left to right, and we find that the next day is 74. So we have to wait 1 day. So 1 goes into here. The next item is 74. Again, we look through the array on the right-hand side of 74. And we find that the next day is 75. We only have to wait for 1 day to get a warmer temperature. Next item is 75. We scan the array from left to right, starting from 75, and we find that the next higher value is 76, which is 4 days away. So 4 goes in here. The next item is 71. 2 days later, we see 72. That is the earliest time point when we see a higher value. So 2 goes in here. The next value is 69, and we only have to wait 1 day to get 72. We have 1 here. Next value is 72. The immediate right to 72 is 76. We only need to wait 1 day. And finally, we have 76. That's the end of the array. So the value is 0 because we are not able to find a higher value. If you have been following this series, you will immediately realize this question is asking for the nearest biggest element on the right. 2 videos ago, we already discussed of using a monotonic stack, and I discussed in detail about the template to do that. If you're not familiar with monotonic stack, I would suggest that you pause this video and watch the first video of this series. I left the link in the description below. There, I discuss in detail how everything works, and also I discuss how we derive the template that you're seeing here. Now, I will continue with this one. For this question, we need a results array where we're going to store the number of days difference between the next warmer temperature and the current one. We are populating the stack from right to left, and the stack, what we're going to store is a tuple, which contains the temperature and also the day. And the day here is basically the index of the array. Because once we find a higher temperature, we can always do a simple subtraction and we can calculate the day when we see a higher temperature and the current day. And that's how we populate results of I. So the results of I would be the top of the stack, and we take the day value minus the current value. Let's walk through several iterations of this code together. We are populating the stack from right to left, so the top of the stack will be on the left side. First item is day number 6. We have temperature at 76, and the stack is empty. The results of I is 0. And then we just push the tuple 76 and 6 onto the stack. The next item is 72, which is on day 5. 72 is a lower number than the top of the stack, which is 76. So we take the top of the stack at day 6, and we minus the current day, which is day 5, and we get 1. So results of I is 1. And then we push 75 and 5 as a tuple onto the stack. The next item is 69, which is also smaller than the top of the stack at 72. So again, we do the subtraction, taking 5 minus 4, and we get 1. So results of I is 1, and we push this tuple 69, 4 onto the stack. Because we are looking for the temperature of a higher value, we are making a stack where the temperature is decreasing. The next value is 71. Now that is a higher value than the top of the stack at 69. So in this case, we will pop the top of the stack, and then we find that 71 is now smaller than 72, the top item on the stack. So we are good. And then we do the subtraction we take the 5 here and we minus the 3 here and we get 2. And then we put 2 as result sub I. And we put 71, 3 onto the stack. The next item is 75. Again, that's higher than the top item on the stack. So we're going to continue to pop the stack until the top item is strictly higher than 75. So we pop those 2 items. Now we do the subtraction. We take the 6 here and we minus the 2 here and we get 4 as result of I. And then we put 75 2 onto the stack. I think now it's clear how the code works and how we populate the result sub I. One can also introduce some optimization here. As you can see, in the stack, you don't really need to store both the temperature and the index because all you need to do is store the index and do a lookup when you're checking whether the temperature is higher or lower. I included here just for clarity purposes. And now let's talk about the runtime complexity. The runtime complexity is big O of n because we are using a monotonic stack. For this, every item is added to the stack exactly once, and they will be moved at most once. Now let's convert the pseudocode into real code. This C# code is provided in the GitHub links below. Everything is very similar as you see in the pseudocode. We have the results array, and we have the stack. And we're going in reverse order to populate the stack using temperatures from the end of the temperatures array to the very beginning. And the end will return the results array. Now let's take a look to see if this works. And it looks good. So next time, we will continue with another example of monotonic stack, and we will do an even more challenging problem. Hope to see you then.